we've been introduced to the idea of double integrals, so let's talk about some properties for them. So we're going to set the ground rules here. One is that I have two continuous functions on some closed bounded region R, and C is some arbitrary constant. So realistically, as long as the space doesn't extend forever, it's a closed region versus being open, so it doesn't include the boundary points and things. Pretty much most of the regions we'll deal with are going to be closed and bounded regions. Anyway, what you'll find is that double integrals behave pretty much exactly the way single integrals do. So the first thing is that if I have a constant multiplied times a function and I'm integrating, I can pull the constant out, just like you can with the canonical integral. The second one is if I have two things multiplied together, two functions multiplied together, added together or subtracted, then I can integrate them separately. Again, things we already do, right? If I do integral of x squared plus 2, I integrate x squared, I integrate 2, I add the results together. This one is the total value of the integral is greater than or equal to 0 if the function's always greater than or equal to 0. And that's not only if. You can still have a positive value of the integral, even if this goes up and down between being positive and negative. But all this is saying is that if this is always positive, then then the whole integral has to be positive. And that makes sense intuitively. If you have a function, the function's always greater than 0, the integral of the function will always be greater than 0. Similarly, this is intuitive. If I have one function value is always higher than the other function, then the value of its integral over the region is always higher than the integral of the smaller one. So these are really useful for estimation and comparison purposes. Think more like proofy type of things, but they come in handy in the sense of if I know A is bigger than B, then the integral of A has got to be bigger than the integral of B. And then finally, what this says is I can take an integral, a double integral, and I can split it up over convenient regions. Think like going back to single integrals. If I was going from the region 0, or let's say I went from like -2 to 10, I could do the region from -2 to 0, and I could do the region from 0 to 10. I could split those up, and it might be more convenient to integrate them by segmenting them. And you'll find that's very true in double integrals because you have to carve up the space in very particular ways. But as long as the regions that you split it into don't overlap and they all sum back up. So basically if you cut R into sub-regions, those regions can't, they can snap together, but they can't overlap, and all the pieces that make R back up have to be there. Otherwise it doesn't make sense, right? If I cut this into pieces, I can put the pieces, I can deal with each piece separately. And again, these are all things you probably could have guessed at, but it's nice to go ahead and talk about them formally before we start using them.